Hello, my name is Justin Castillo, and this is my submission for Programming Assignment 4, the implementation of the banker's algorithm for deadlock avoidance. So the number of customers or processes is 5, number of resources is 4. Here we have our data structures, our available array, which is the amount of each resource that is available, and then the other three are 2D arrays corresponding to a customer and a resource type. So this one would be the maximum amount of this resource that this customer needs. This allocation is the current amount of this resource that this customer has, and then need would be the max that we need to fulfill minus what it currently has. And so I didn't know if there would be a specific file name, so I use max.txt as a default. Otherwise, you can pass in a file on the command line. So this is my max.txt. So as we can see here, there are 5 customers, 0, 1, 2, 3, and 4. And there are 4 resource types, 0, 1, 2, and 3. So it would be customer 0, resource type 1, the max that it can have at any time is 6. So this is all the file logic. We grab the maximum from the file. We input it into the maximum array. We initialize allocation to 0 since we haven't started yet, so none of the processes have been allocated anything. We initialize need to max since they haven't been allocated anything, so max minus 0 is still max. And then we go through, we enter the loop, which runs until a user enters exit, when we immediately jump to exiting program down here. Otherwise, if the user starts with RQ and then the customer ID and the amount of each resource requested, this would be a request. So what we do is we check if it's in the right range. If it's negative, then we just print an error message and prompt the user again for another request. And then we invoke request resources, and then this would invoke the isSafeState function to check if this request would end with a safe state. If so, it grants it. If not, it denies it. Same thing for if it's RL, grabs all the maximums and the customer and the process ID from the command line, checks if it's in the right range, checks if it's negative, and then checks that it also checks that the number of resources it needs to release is less than or if it's greater than the number of that resource that customer currently has, then it's just prints an error message and prompts for the next input from the user. And then invokes release resources, which itself invokes isSafeState, and then confirms that the request was granted. Star invokes print state, and then we exit the program, and that's it for main. So isSafeState is sort of the key function here. We create a copy of the available array called work, and then just an array of finish to keep track of the finished states of each process. So we initialize the work array, which is just a copy of the available array. And then we initialize all states to false. We loop until the customers have all finished. So we loop through the customers, and then we check first off if the amount that is needed from this process of this type of resource is greater than the amount of this resource available at that given time. Then we break out of this for loop, and we go on to the next customer, and it's not finished. And then if this is not true, then it enters this loop, which pretends to both allocate and then release all of the resources back into work, so back into the available array, the copy of the available array. It sets its finished state to true. It increments this counter, which is used to finally check if the ending state is safe. If the finished count is equal to the number of customers, then all the customers were able to finish, and thus it was a safe state, so the request would be granted. And we add, and then this is just a check that if it doesn't find any processes, that's what found is. So we loop through. If they're all able to finish, we return 1, otherwise 0. These are called by both release resources and request resources. So for request resources, we check that if the request is greater than number of resources the customer needs, then that's an invalid request. We immediately deny the request. If the request is greater than the amount available, then that's an invalid request. That is denied. We then pretend to allocate the resources, so we take away the requested resources from available. We allocate them to the customer. We deduct those requests from requested resources from the customer's need, and then we invoke isSafeState, which goes through all that I just went through. If so, it returns 0. Otherwise, it undoes. It inverts this and then returns -1 to deny the request, so we can the loop keeps going as if the request never happened, except we know that it's an invalid request. And then release resources works pretty much, it's just checking that it's, release resources is much simpler. So, and then print state is just printing, looping through each of the arrays and printing them nicely. So I'll go through here. I'll enter this one. So right away we see that allocation is 0. The need corresponds to the max here. And so I'll go ahead and do in a request that should be granted. And then we see that request was granted, and we see that the allocation was updated appropriately, and the need, so this was customer 0, so 6 minus 3 is 3, 4 minus 1 is 3, 7 minus 1 is 6, 3 minus 0 is 3. So we see that that was appropriately granted. And then this one should be denied. And this is denied. So let's print out just to make sure. Right, well, it was already allocated here, so nothing was changed from this state to this state. So it should be good. And then we exit. So all of the functions work. A bug I ran into was I put this, what did I do? I put return 0 inside this while loop so that it exited as soon as any one request was made, any of the RQ, RL, star, or a star, they would all just, do the right thing, but then immediately exit. So I just had to put this outside of the loop, and then I had to account for the, just making sure that it's robust to have a file or a default called max.txt. So I did use GPT to debug and clarify the concepts and just make sure that to develop tests and just sort of double check everything was correct. Um, the pseudocode from the slide was pretty explicit, so it wasn't too difficult um, to implement. Let's see. So it ensures mutual exclusion because um, it cannot allocate more than the available resources to any, two programs. It the number of resources is the number of resources that they don't the maximum the number of resources available is not modified here, so each process cannot lay claim to more resources than are available. So um, for progress, um, since the uh, the loop goes through all the customers and checks them, um, it will never, stall infinitely in one place. So there's no chance that it won't that a resource will be uh, denied infinitely or for an infinite amount of time. And then for a bounded wait, um, yeah, progress and bounded wait are pretty similar. Like bounded wait, each resource is considered, you know, immediately one after the other, so there's no chance that one will be skipped over infinitely. Um, and I believe that is everything. Thank you for watching.